Hai, Assalamualaikum dan salam sejahtera. Salam ke ITN yang hati. So today, me and my member like to conduct one experiment coefficient of Orifice. So today, I would like to introduce our member.
Hi, my name is Siraj from class 2A4A.
Hi, my name is Hafiq from 2A4A.
Hi, my name is Muhammad Kadir Azami bin Arif, class 2A4A.
Hello, my name is Haris Ikrim Hisham. I'm from class 2A4A.
Okay, so I will talk about our introduction. So the Orifice coefficient experiment is designed to study the flow characteristic of a fluid through an orifice or opening. The flow velocity and discharge are calculated based on the Bernoulli's equation should be correct to include the effect of energy loss. Therefore, for accurate result, the coefficient of velocity CV, coefficient of acceleration CC, and the coefficient of discharge CD should be calculated for an orifice. The orifice coefficient, which is a dimensionless number, is used to calculate the flow rate through the orifice.
The theory behind the Orifice coefficient experiment is based on the principle of fluid dynamics. When a fluid flows through a different diameter pipe, it experiences a change in velocity. The discharge formula states that the area of the pipe is inversely proportional to the velocity. Therefore, as the area pipe increases, the velocity will decrease, such as the equation V equal to Q over A. In this experiment, the Orifice coefficient will be determined by the measuring the distance in Y and X direction of the water flow through the orifice. This will be done using different orifice diameter to study the effect of this variable on the Orifice coefficient.
Next, let's talk about the procedure. Our first test, we are using 0.04 of diameter. First, make sure the pipes are connected properly to allow the water to flow through the pump into the tank. Next, regulate the inflow water when the water level reach the height of the overflow pipe. Then, we measure the height of water to 38 cm and record the values of H0 and Hc. Adjust the needles, follow the band of water flow at orifice. Next, plot the points based on the top of needle position. Lastly, we calculate the flow rate of water by using stopwatch and measuring cylinder. Then, repeat the procedure by using 0.08 meter of diameter.
data that we can obtain from the experiment is diameter of Orifice, distance is y, distance is x, and the head level. Our team has used diameter of 0.04 meter for the first variable and 0.08 meter for second variable. While for the head level, we use constant value for the two diameters of Orifice, that is 0.38 meter. The last column in table, we obtain all the value by using formula square root of distance in y times head level. All the value in the table will convert into meter. For the graph, we plot the graph from data we obtain. The distance in x will represent as y-axis, and the value of square root yh is used for x-axis. This data that we collect is to obtain the value of flow rate and the time of the water flow. This is all the samples of calculation. In this experiment, we need to find three values, that is value coefficient of contraction Cc, coefficient of discharge Cd, and the coefficient of velocity Cv. To find the value coefficient of velocity, we use formula that is velocity jet at vena contracta divided by square root of 2 times gravity and time value of head level. While to find the value of Cc, the area of vena contracta will divide by the area of Orifice. To find the value coefficient of discharge, we just need to time the both value of Cc and Cv. All the formula we use same again for the both value diameter of Orifice.
So we go to the discussion. From graph distance in x against square root of yh, we are conclude that x is nearly proportional to square root of yh, where most of the values are consistent. But there are vertical lines in the graph that cause the result inaccurate and graph not perfectly proportional. This is due to error occur in the experiment. From the graph, we can observe that when the diameter of Orifice increases, the volume discharges also increases. Therefore, we can conclude that the diameter of the orifice is directly related to the pressure acting on the volume of water in tank. But there are some error occur in the experiment, which is parallax error with the apparatus used. The tube have air bubbles inside it, so make sure there's no air bubble at the tip of tube to get accurate reading. Other than that, we obtain an accurate result caused by parallax error while taking the height of water. So the precaution is the observer's eyes must be perpendicular to the scale of the reading to avoid parallax error.
Okay, so I will talk about our conclusion of the project. So the conclusion of the experiment is the Orifice coefficient experiment provide valuable insight into the behavior of fluid flow through an orifice and the factors that affect it. We have successfully calculated the coefficient of discharge, coefficient of contraction, and coefficient of velocity, as shown on the slide previous. The results of the experiment show that the orifice coefficient is affected by the diameter of orifice. We also can conclude that the increase of the diameter of orifice will increase the volume of fluid discharge as pressure acting on it increases. This experiment has important application in various industrial process and systems.